Welcome students. Today we will learn about quadratic series and sequences. Thereafter, we will take a look at two past year questions, one of which is quite simple and the other requires some good thinking. Let us begin. The quadratic series is the same as the quadratic equation, ax squared plus bx plus c. The quadratic series formula is an squared plus bn plus c. The only difference is we've got n in the place of x. N is the nth term of the quadratic series. So we have our first term, second term, third term, and fourth term. And this goes on to infinity. Now let us substitute the values of n into the quadratic equation. Now we can find our first difference. Now we can get our second difference. And that's it. So we've got our second difference, our first difference, and the quadratic sequence. So you must be wondering, why did we do this lengthy process? Well, now we have the solution to the quadratic series formula. To summarize, the first term is equal to a plus b plus c, and this is for the quadratic sequence. We know the first difference is equal to 3a plus b, and this is for the first term of the first difference. The second difference is equal to 2a because the second difference is constant. This means our first difference is in the form of an arithmetic sequence. Now that we have accumulated this knowledge, let us use it to solve question 3. We will first work through this fundamental question. The first four terms of a quadratic number pattern are -1, 2, 9, and 20. 3.1 wants us to determine the general term of the quadratic number pattern. We know the general formula is Tn equal to an squared plus bn plus c. We need to determine a, b, and c. Let us find our first difference. Now our second difference. At this point, we know our second difference is equal to 2a. Our first difference is equal to 3a plus b. And our first term of the quadratic sequence is a plus b plus c. The best way to work through this is starting from the second difference. So 2a is equal to 4. Therefore a is equal to 2. Now 3a plus b is equal to 3. Therefore b is equal to -3. Now we can determine c. So we've got 2 plus -3 plus c equal to -1. Therefore c is equal to 0. We can write the final form. Tn is equal to 2n squared minus 3n, and this is our general solution. Now let us move on to 3.2. Calculate the value of the 48th term of the quadratic number pattern. Here, n is equal to 48. Therefore, we can substitute 48 in the place of n. So T48 is equal to 2 multiplied by 48 squared minus 3 times 48. And this is equal to 4,464. Now let us look at 3.3. Show that the sum of the first differences of this quadratic number pattern can be given by Sn equal to 2n squared plus n. What does this mean? We need to break down this question. Firstly, they want the sum of the first differences. Remember, the first differences is in the form of an arithmetic sequence. That equation is Sn equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d. Here, a is the first term and d is the difference. The first term of the arithmetic sequence is 3. The difference is 4. Now let us substitute these values into Sn. Remember, the question wants us to prove the summation solution. So we have Sn equal to n over 2 multiplied by 2 times 3 plus n minus 1 multiplied by 4. Therefore, we've proved Sn. Now let us move on to the last part of the question, 3.4. If the sum of the first 69 first differences equals to 9591, which term of the quadratic number pattern has a value of 9590? The easiest way to do this, take Tn equals to 9590, and this is one of the terms of the quadratic number pattern, so we've got to solve for n. We let this equal to the general solution, which is 2n squared minus 3n. So to solve for n, we need to solve this quadratic equation. We begin by factorizing. And now we have n equal to 70 and n is equal to 68.5. This solution is not applicable because n is an element of integers. So n is equal to 70, and this is for 2 marks. Now let us move on to a more interesting question. The first 4 terms of a quadratic number pattern are -1, x, 3, and x plus 8. The easiest way would be to find the first and second difference. Now we have our first difference and our second difference. We know that for a quadratic sequence, the second difference is constant. Therefore, we can equate these two differences and solve for x. So let us simplify this expression. Therefore, x is equal to 0. We can now move on to 3.1.2. If x is equal to 0, determine the position of the first term in the quadratic number pattern, for which the sum of the first n first differences will be greater than 250. Let us deconstruct this statement. Normally when we have the words for which, we tend to work with the second part. The sum of the first inverse differences will be greater than 250. So this is the sum of the first difference. And they are asking, when will it be greater than 250? The summation formula for the arithmetic sequence is Sn equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d. A is the first term, d is the difference. Here, our first term is 1 and our second term is 3. This is by substituting x equal to 0. We can now substitute these values into the summation formula. Sn is equal to n squared. Remember, they want to know when will the first differences be greater than 250. So n squared greater than 250. And n will have to be greater than 15.8. Now n is an element of integers, so we round up. When n is equal to 16, the sum of the first differences will be greater than 250. Let us take a look at the first part of the question. Determine the position of the first term in the quadratic number pattern for which the sum of the first n differences will be greater than 250. So we found n for the first difference, which will give us a summation of greater than 250. The question wants us to find n of the quadratic number pattern. Here, n is equal to 16, and for the quadratic number pattern, n will have to be 17. Watch carefully. This is n1, n2, n3, and n4. Now for the arithmetic sequence, or rather the first difference, we would have n1, n2, n3. You should notice that the first difference terms is one less than the quadratic series terms. Like here we have n1, but the following term is n2. Here we have n2, and the following term is n3. So the first term in the quadratic pattern, for which the summation of the first differences will be greater than 250, would be n equal to 17. This question required some intuitive thinking. You would need to understand the English and break up the question. Thank you for watching. Bye.